Hey everyone, welcome back to Code Streak Daily. In today's video, we are going to solve two smallest in every subarray, and it's an easy level problem. So let's check the description here. Let me read out the description. Given an array of integers ARR, the task is to find and return the maximum sum of the smallest and second smallest element among all possible subarrays of size greater than 1. If it is not possible, then return -1. Okay, so it's a really interesting problem. We have to find the maximum sum of the smallest and second smallest elements in the subarrays of size greater than 1. So let's see how we are gonna implement that. Here we have an example. Here there is an array with elements 4, 3, 1, 5, 6, and the output is 11. So here we have the explanation. Here there's a subarray 4 and 3. The smallest element among these is 3, and the second smallest obviously will be 4, and the sum will be 7. Then we have the subarray 4, 3, and 1. The smallest will be 1, and second smallest will be 3, and their sum would result in 4. We have another subarray 4, 3, 1, and 5. The smallest will be 1, second smallest still 3, sum will be 4. And we have the whole array subarray. Smallest element will be 1 and second smallest will be 3. The sum will result in 4. In the same manner, we have all the subarrays possible for the given array. So we have to find the maximum among all the sums. So at the last we have the subarray 5 and 6. Here the smallest will be 5 and second smallest will be 6, and their sum will result in 11. And the maximum sum among all the above choices is 5 plus 6 equals 11. So the answer will be 11. And we have another example with only one element 1, we have to return -1, because here the size of the array is 1, but we need minimum 2 elements to compare between the smallest and second smallest. So we have to return -1, and the expected time complexity will be order of n, and space complexity should be order of 1. Okay, the task is simple to understand, but it requires a bit of thought to solve it efficiently, right? So we are given an array. We have to find the maximum sum of the smallest and second smallest elements among the all the subarrays, right? So now let's see the key inside here. Instead of generating all the subarrays, which would be inefficient, we can focus only on the adjacent elements in the array. We'll have a question why, because any subarray of size 2 or more will include at least one adjacent pair. So if we calculate the sum of every adjacent pair, we'll capture the required information efficiently. Okay, so instead of generating all the subarrays, we'll just go on checking with the adjacent elements only. Okay, now here we have the class solution, and there's a function inside with a pair with maximum sum, and here array is passed. So we have to check the basic condition that if the length of the array is less than 2 elements, then we have to return -1. So if length of the array is less than 2, then we are just gonna return -1. Okay, now we check that if the array has fewer than 2 elements, we have to return -1. Okay, now we are going to take a variable max sum, and we are going to initialize it to a very small number. Okay, like -infinity, to ensure that any sum we calculate will be larger than this initial value. Okay, so I'm taking max sum equals to float of -infinity. Okay, now we have to traverse through the array and check the sum of the adjacent elements in the array, right? So I'm taking a for loop for I in range of length of array -1, because we should not traverse until the end of the array. We have to traverse till the last but one element, so that we can compare the adjacent elements of the array. Okay, so I'm taking a variable current underscore sum. Okay, so current underscore sum will be equals to array of I plus array of I plus 1. Okay, now what we have done, we have to loop through the array, and for each adjacent pair of elements we calculate their sum, and it gives us the sum of the current element and its next element. Okay, now we have to check if current underscore sum is greater than max underscore sum or not. In that case, we are just initializing the current sum value to the max sum value. Okay, okay. Now we have updated that. This ensures that by the end of the loop, we'll have the maximum sum of the adjacent elements. Okay, now we are gonna just return the max sum. That's it. Now let me check that if this works or not. Yeah, our output is perfectly matching with the expected output, and let me submit and see. Yeah, it's perfectly working. Now you see that there is an accuracy of 100% and the time taken is very less. It's 0.07 seconds only, right? And all the test cases are passed. Now um, let's consider an edge case for this problem. What if the array has only one element, like array of one only? So we have to return only minus 1, right? And there we have it. We efficiently solve this problem, and with a time complexity of order of n only, because here we have used a for loop, and we have looped until the end of the array. So the time complexity will be order of n and the space complexity will be order of 1 only, because instead of generating all the subarrays, we just focused on adjacent elements, which made our solution both clean as well as fast. Okay. Now, if you found this video or explanation helpful, don't forget to hit that like button and do subscribe to CodeStreak Daily for more daily problem solving videos. And also leave a comment if you have any questions or suggestions for this problem. And if you have any code efficient than this, do put that in the comment. I'll surely check on that. Keep streaking, guys.